Jai Hind. As part of the MRO Digest, I'm today going to talk to you all on rare earth elements in Indian context. Why is it called rare earth? This rare earth was discovered somewhere in 18th century, to be precise in 1788 in Sweden. And why is it called rare earth? Rare because it was the first time it was discovered, so it was very rare to get this metal. And second, this rock which was there, it used to get diluted in acid. So anything which used to get diluted in acid, they used to call it earth. So that's how the terminology rare earth got defined. Now you will say, what is this rare earth all about? Rare earth, you know, if someone says gold is rare, I can always say that this is nowhere, it is more than the gold which is available in the earth as such. Today, total gold which has been extracted out of earth is 2,44,000 tons, out of which 1,87,000 has been already converted into jewelry or kept as reserve, and only 57,000 tons of gold is available underground. Coming to rare earth is actually, as on date, what has been discovered is 144 million tons available. Today, China produces approximately 2.1 ton of rare earth every year, which is approximately equal to the total gold available in the earth. So rare earth is 500 times more than gold. So you can't actually call it rare earth, but the terminology was given long back. So we are continuing with that terminology as such. Otherwise, it's available in plenty. With this as the background, I will cover my presentation at the following heads: introduction, application and civil and military, global overview and Indian scenario, strategic importance of rare earth elements in India, the opportunity and concern for us, the consequences and recommendation. Coming to the introduction, you are all familiar with this. This is the periodic table. If you look at on the screen, this SC which I am pointing through my mouse and Y are the rare earth, and this LALA. The expansion of LALA are these lanthanides. These 15 lanthanides and these 2 cerium and yttrium, they constitute the rare earth as on date. These rare earth are a group of 17 elements, out of which 15 are the lanthanides, from atomic number 57 to 71, out of which the low rare earth element, when I say low rare earth element, are this La to Sm. These actually in the rock, their content is very low. So extraction process is more cumbersome. Whereas the high rare earth are from Z63, that is atomic number 63 to 71, starting with europium till yttrium. Now, if you look at what are these rare earth elements, these rare earth elements, if you expand, they all stand for lanthanum, cerium, sodium, neodymium, promethium, and samarium. They all look Greek to us in terms of the way, but they were all derived at the place. Either some have been named over the city, some were named over the scientist's name, something like that. The higher rare earth are the europium, gadolinium, terbium, dysprosium, aluminium, erbium, thulium, yttrium, lutetium, and scandium and yttrium are the Sc and Y. What are the properties of rare earth? They have unique catalytic, metallurgical, nuclear, electrical, magnetic, and luminescent properties. Very rare to have a metal like this, which has got so many properties. So they display high density, high melting point, high conductivity, and high thermal conductance, finding applications in different fields. They are strategically very, very important due to emerging and diverse technology from daily use to futuristic technologies. They are always found in minerals with thorium, and the extraction, I said, is a very complex procedure. It is easier to extract HRE, that is the higher rare earth elements, than the lower rare earth elements. What are the application in civil and defense? So come to starting with the civil application. If you look at this graph, the 70% of rare earth is used as catalyst. I'll explain this later. 10% is used in ceramic complete glass manufacturing. 4% is for use for polishing. 6% is used in metallurgy, and others are 6%. If I expand it further, this slide gives you the complete usage of rare earth element as such in civil application. Starting with magnets. These are the rare earth which get used in making of magnets. These are the rare earth permanent magnets. That is the neodymium, praseodymium, samarium, terbium, and dysprosium. Where are these rare earth magnets utilized? They are utilized for motors and generators, HD drives, microphones and speakers, for MRI scan, various defense application, and in magnetic refrigeration. Coming to the metal alloys, you have the lanthanum, cerium, praseodymium, neodymium, yttrium used for making the metal alloys, also used for NIMH batteries, in super alloys, aluminum, magnesium alloys, and in steel manufacturing. Used as phosphorus, where the europium, yttrium, terbium, neodymium, gadolinium, cerium, and praseodymium are used in manufacture of LEDs, laser, flat panel display, fluorescent lamp, X-ray imaging, optical sensor, and fiber optics. As I said, the 70% is used for catalysts. These are the catalysts in chemical process. What is used is lanthanum and cerium, along with praseodymium and neodymium. They're used for petroleum refining, automotive catalyst. One of the catalytic converter also has this diesel additives and water treatment. And in ceramic and glass, you have cerium, lanthanum, praseodymium, neodymium, gadolinium, erbium, and aluminum being used for polishing media, ultraviolet resistant glass, thermal glass, capacitors, sensors, cool colorants, refractories, fuel cells, and superconductors. All others are used for fertilizers, pigments, nuclear, and medical tracer. Coming to proper application, bit by bit, rare earth element by element, you can have a look that the first 6, which are in red, are available in plenty in India, and the balance which are available in dark blue are very rarely available. But these first 6 which are available in India are the LRRE, that is the content, they are low rare earth elements. So extraction process is much more difficult. You can see where all they are used. I already covered them. But if you want to see individually these rare earth elements, how they are, each elements, how they are utilized in which all industry is given in these slides. Coming to application in defense, I have divided into 3 columns. First column is what are the rare earth metal, what are the instrument in defense, and in which part it is utilized. So that is what it gives. So if you look at the rare earth metal, dysprosium, neodymium, praseodymium, samarium, and terbium, these are used in gyros and accelerometers, which are further used in anti-ship cruise missiles, surface-to-air missiles, precision-guided missiles, and smart bombs. The europium and neodymium, terbium, and yttrium rare earth are used in lasers for determining the range of enemy targets, laser interrogators for enemy detection and countermeasures, enemy mine detection, and underwater mines. The dysprosium, erbium, europium, neodymium, praseodymium, terbium, and yttrium, they get utilized in the communication equipment for satellite communication, radar, sonar, submarine, and surface ships. Now, if erbium, which is one of the rare earth, is added to vanadium, which is a metal, to make it more malleable for use in vanadium infused steel that goes into jet engine. It gets utilized in aircraft and naval ships and submarine. You'll be surprised to know that the F-35 fighter, which the USA brings out every now and then, has got 417 kg of rare earth. Their air-leg Burkett destroyer has got approximately 2,300 kgs of rare earth. Their SSN Virginia class submarine has got approximately 4,000 kgs of rare earth. So this kind of rare earth is used in our ships, in our fighter aircraft also. Those figures are not part of the public domain. Neodymium and samariums are used in the computer systems or in permanent magnets, which gets further utilized in the computer disk drives, hybrid electric motors, wind turbines, and all modern military equipment which are highly dependent upon computer system also use them. The yttrium and lanthanum, which we have large numbers in India, are used in electronic warfare. It could be for the high capacity power source, in storage batteries, in jamming device, and also used in nuclear detection system to detect gamma rays. Now, looking at after seeing how this rare earth gets utilized, let's look at the global overview and the Indian scenario. If you look at the global reserve of rare earth, the y-axis gives the approximate tonnage and the x-axis the countries. If you look at China, China has got 44 million tons as global reserves of his own reserves of rare earth. India has got 6.9 million tons, which is more than Australia and USA. Now, if you look at the total reserves of the earth as such, in 2010, we had 110 million tons, and in 2020, we have 130 million tons. So if you can imagine 130 million tons, whereas gold was only 2.1 lakh tons, and we are so crazy about gold. So the availability of rare earth is plenty, and is in plenty in India itself, 6.9 million tons. There's another slide which gives you a little bit, how the rare earth came about. This graph, actually, the y-axis gives you the tonnage production year by year, and the x-axis gives you the year. The yellow line depicts others. The blue line depicts USA. This red portion is China, and this green portion is Australia. Now, if you look at it, this mining of rare earth was started by USA company in 1965. And some other countries are also producing it. Somewhere in 1983, China entered this business, subsidized all its factories, and started pumping rare earth at very cheap rates into the world. You look at this, suddenly the production of USA started decreasing, and somewhere in 2002, 2003, the USA stopped mining because it was not economical. So at that time, only China was the major rare earth producer, and in somewhere in 2005, China had a global share of 98%. This, once it had a 98%, somewhere in 2011-12, China put a little bit of, not a ban, I will put it, reduced its export to especially Western countries. For one thing, they didn't want these Western countries to develop their own technology using rare earth. So just reduce the export, due to which the America started producing its own rare earth again in 2013. And you can see this blue line coming up. Today also, China controls 70% supply of rare earth to the world, and USA does about 14% of rare earth to the world, and balance is by the rest of the world. You can see the bottom, Australia has suddenly taken off somewhere in 2014 and is one of the major suppliers it has become. Remember, Australia has got less reserve. Australia and USA has got less reserve than India, but is producing much, much more than India. This is another graph which will make it much, much more clearer. This red depicts China, blue is USA, cyan is Russia, yellow is others, and green is Australia. If you look at it, again, as I said, somewhere in 2003, USA stopped, and after that, China took over, and somewhere in 2013, USA also once again entered. But the best part is, somewhere the Burma has entered in a big way, and Burma, which has got less reserves, has got more production capacities than India. Similarly, Australia, which is in green, has got more production capacity than India. Production in 21 and 22, just to say, where are we recently? China is still dominating with about 2,10,000 production in the year 22. Then next comes is USA with 43,000 production. Then Australia with 18,000. India is very low production, is only 2,900 tons. Russia is also 2,600 tons. Here it is Myanmar. Myanmar last year produced 35,000 tons. And last year, when I say is 21. And in 2022, it produced 12,000 tons, much, much higher than India. Whereas the reserves are less there. Now, what are the strategic importance of rare earth for India as such? India rare earth reserves are richer in LRE and deficient in higher rare earth elements, hence complex processing, which I told you before. Exploration is conducted by Bureau of Mines and Department of Atomic Mass Energy. This Bureau of Mines comes under the Department of Atomic Energy. We have large unexplored reserves. Exploration, this is costly. Every 3 to 5 years, a new use of rare earth material is being discovered. The pattern of the rare earth changed significantly in every decade. 1962, the color TV first time came, the rare earth got utilized, and rare earth was commercially utilized in a big way. Today, rare earth is used in military equipment. The usage keeps on changing every decade. Extraction, as I said, is a very complex process. Now, if you look at this slide, the column first gives you the country. It says the percentage of global reserves and contribution. China, which has 37% of global reserve, is contributing to 70% of production every year. India, which has got 6% of the global reserve, is contributing only 1% of production or supply to the world. This is how the China is able to dominate the rare earth element and is able to put value in supply chain. This is where India has to use economic and logistic for strategic objectives by ensuring that we invest in rare earth, produce more, export more, start making rare earth permanent magnets. Now, where does it occur in India? It occurs in most of the beaches which have got manzanite. It occurs there. For example, in Pudukkottai, Tamil Nadu, a Chavara deposit in Kerala, red sediment in Tamil Nadu, in Satanikulam, in Tandara, Varaha coast in Visakhapatnam of Andhra Pradesh. And this is, I'm listing it out. The first column gives you the element. Locations are generally the same. The resources are same, which is the third column. What I written is a percentage. If 100% rare earth, if we take, 22% of lanthanum is held by India. 22% of rare earth is lanthanum. Cerium is 46%. Neodymium, which is used for making permanent magnet, is 20%. Like that, we have percentage. The first 6 till samarium are the low rare earth. After that, if you see, the percentage is decreased 0.8, 0.1. These are the high rare earth element. And there are 3 rare earth elements which are just not available in India, which is thulium, ytterbium, and lutetium. And balance are available in minuscule quantity. There's an extraction process for this rare earth. It's a simple mining process, very easy to understand. The ore is crushed into gravel size. This gravel is milled into silt. Flotation process used so that RE could be extracted, monzonite. Then the RE is separated from mineral. They are oxidized and then they're turned into metals. These oxides are turned into metals and into alloy and then used in for high-tech application. Where they're generally used is in the green energy, hybrid electric vehicle, water treatment, defense technology, and high-tech technology. Now, what are the opportunities and what are the concerns? The current scenario, as I told you, this graph gives you the percentage contribution of rare earth by each country. If you can see, China is 70%, India is 0.97, is approximately 1%, and USA is 14%. The second column is USA. India has got a low production with limited resource base explored. China, world largest producers with large resource base. USA and NATO are looking for alternate supply lines. 40% of American companies in China are considering to exit from China. This is a huge opportunity for us. But unfortunately, Southeast Asia, that is Malaysia, Vietnam, Thailand, these are the preferred location. Only 8.4% considered Indian subcontinent. Now, what are the potential rare market itself in India? The magnets for wind turbine, where this neodymium, praseodymium, diporium, and tiberium is utilized. Present status, we are able to produce 42,000 megawatt of wind power today. It is expected to go up to 140,000 megawatt power. Approximately $200 billion business is going to be. Imagine the amount of rare earth which is going to get utilized here. Because 30% is rare earth utilization. In the electric vehicle, in the hybrid vehicles, used for the motors, catalytic converters, and other things, lanthanum approximately 15 kg per car. Neodymium 1 kg per car. Today, I say negligible electric vehicle compared to petrol and diesel vehicle, but up to 1 million vehicle will get sold every year. It's a $1 billion industry. Similarly, LED TV bulbs. Today, the present status, yes, we have expanded, but scope is it's going to go to 100 million every year. Aluminum, steel, manganese, grain refinement, huge growth rate and a growing market. Screen brightness, basically for cell phone, computers, and TV. Europium, these are mostly imported. It has got a huge market when anyone who's making mobile or TV. And in other magnets also, sodium, samarium is utilized, and these are mostly imported, used in the computer hard disk and in microphones. So there's a potential market. So if we grow our rare earth and produce sufficient, we will have the capacity to absorb them. We will need not import them. Plus, we will be able to export and earn some foreign exchange. Yes, as I said, foreign exchange. Coming to the economic issues, India imported about 800 tons of rare earth in 2022. I mean, you will say this is not much, 800 tons. We are ourselves producing approximately 4,000 tons every year. Today, let me tell you, we are not manufacturing rare earth permanent magnets, which are used in electric vehicles, which are used in motors, generators, and other equipment, we are also importing this. If we can not only make rare earth permanent magnet, it will all get utilized in your wind turbines, in all other magnet where the magnet is used, you will be able to export them also. Second, we are in Atmanirbhar, we are making defense equipment, but we are not yet started making defense equipment where large amount of rare earth is being utilized. Again, same goes to rare earth permanent magnet and other parts. So when these things get started producing in India, we will be importing a lot of rare earth. Today, government does not have the kind of funds that is needed for exploring this rare earth and for producing. That is why we need to encourage the private sector to come. So as I said, this import is when India does not make REPM, that is a rare earth permanent magnet, defense equipment, LCD panels. China last year exported 44,000 tons of rare earth for approximately $8 billion. The allowing for private players will invite foreign JV and the technology required for rare earth permanent magnet and for other items. Wind energy, electric vehicle, LCD, cell phones, computer industry will expand exponentially if rare earth becomes cheaply available in India. It will be if we explore more, we produce more. Increase in rare earth production will speed up India becoming a 5 trillion economy, because we will be not only will be able to make rare earth permanent magnet and other items, we will be able to export more and tap into this 8 billion which China is making. We will also be able to take something out of it, and it is only going to increase. The usage of rare earth is only going to increase and not decrease. Some salient issues with respect to rare earth, with respect to India. Coastal sands in Indian Ocean region is a large repository of rare earth elements containing monazite. Monazite is the basics on which from rare earth is extracted. The countries affected in the IOR, India, Myanmar, Madagascar, and African East Coast also. Along with rare earth elements, monazite also contains thorium and uranium tailings, which are radioactive. Indian private sector cannot handle nuclear material. This is one of the basic reasons why the government is not allowing the private sector to enter this rare earth element industry. Why? Because when you process this manzanite, you are going to get thorium and uranium as side elements of rare earth. But because the opportunity is there, Indian government should do a quick and better response to the strategic needs and market dynamics, because this rare earth is going to get utilized in a big way, and this is an opportunity for India. Today, in India, the primary mineral is the monazite, from which we are making, and our capability is 4,000 capability. We're producing 4,000 tons per annum, but our capability is 10,000 tons per annum. We have the capability, but we are producing only 4,000 capability. Facility for separating this radioactive elements from rare earth elements can be established by cracking monazite post change in the policy. The government of India will have to change the policy which is existing today. Revising the policy will create large stockpiles of thorium and uranium with the Department of Atomic Energy when this nuclear fuel cycle develops. Need to have a storage policy. Uranium recovered from these domestic dead stockpiles using Indian companies will be outside the purview of safeguards under civilian nuclear program and will be available for dual use by Department of Atomic Energy. NATO and Quad would welcome critical rare earth element supply lines away from Chinese influence, and India could be exporting rare earth permanent magnet within a couple of years if the policies change and the private players are allowed to come. What are the benefits we will get if we get into the rare earth in a big way, where we allow the private sector to come? First of all, we'll get foreign JVs. They'll come and they will be attracted toward the private Indian industry for exploration, mining, and in rare earth permanent magnet manufacturing and supply chain. Huge demand exists for non-China rare earth permanent magnet, will send positive signal and encourage downstream manufacturing to move to India, leading to huge EV manufacturing. Immediate boost to rural employment in exploration and mineral sand mining. High-paying jobs will raise the income level of village and small town and increase secondary business and employment. This will also raise costs for China, as it will be forced to continue subsidy to compete with Indian rare earth permanent magnet. That will be the byproduct of mineral sand mining. Green power technology, that is windmill, industry will boom as wind power turbines being imported from China will be manufactured domestically. Domestic rare earth permanent magnet availability can create electric motor manufacturing boom and will provide major incentive for electric vehicle manufacture. Positioning India to meet NATO requirement of rare earth permanent magnet for their defense industry and diversifying defense material supply away from Chinese influence will also be beneficial. High technology rare earth element metallurgical research in India will improve and we'll get better products. This boost to this industry will speed up India becoming a 5 trillion economy at an earlier time frame. Suppose we don't and we continue the policy similar what we have now and no change in policy is done, what will be the consequence of delay? India will miss the boat first. The downstream rare earth industries are likely to move from China to Mexico, Canada, Vietnam, or Thailand. As China moves to control rare earth element supply chain in Indian Ocean region, Indian industry will perpetually be dependent on China for NATO countries are already considering non-Chinese supply chains. Delay in decision making will cause these countries to freeze supply chain outside India. Delay will give Chinese companies time to ring fence metallurgical research with global patent, and we'll lose the boat. We'll lose the time lag there also. My recommendations: we need to have a de novo, that is fresh look at the policy for rare earth elements for private players for extraction of rare earth elements. Access to rare earth element processing and downstream product technology should be allowed. Exploration of rare earth element deposit in India for raw material of spherium, pneumodium, premium, and dysprosium. Exploit rare earth non-Chinese supply chains for countries across the globe. Self-reliance in rare earth elements in domain of defense needs. Today we are importing them. facility for storage and utilization of all rare earth elements post extraction, that is uranium, thorium, and all elements which we get. A fresh look at environmental policies versus extraction of rare earth element is an absolute necessity. With this, I finish my presentation. I would like to acknowledge and thank Dr. Amit Tripathi, who contributed to me in making this presentation. Jai Hind.